Okay, so let's start this review worksheet. We're on number 5 from class, where it says find the area between f of x is equal to 2x squared minus 3x plus 1 and the x-axis on the interval of 2 to 1. So I've put the graph up on the screen, and we can see clearly that the x-intercept is at the point 1, 0, and since we're going to the interval of 1 to 2, we see that at 2, this is the point 2, 3. It's not really as important of where it meets at the value of x equals 2, but it's just good information. So this is actually pretty straightforward since we want the area between this and the x-axis. So we're just going to do a straight integration from 2 to 1 of f of x. I fast forward a little bit and write the equation. All we're going to do is apply our rules for integration. Remember, it's to the power of n plus 1 over n plus 1 at the value of 2 and 1. Okay, so we integrated. Now we're just going to plug in our bounds. Remember, we plug in the upper bound first. So we have 2 times 2 to the third over 3 minus 3 times 2 squared over 2 plus 1 times 2. And we want to subtract the entire lower bound. So we have 2 times 1 to the third over 3 minus 3 times 1 squared over 2 plus 1 times 1. Don't forget, this is an important thing. We're subtracting the whole second term. So as we evaluate this, you end up with 16 thirds minus 6 plus 2. Distribute the negatives, so now we're left with negative 2 thirds plus 3 halves minus 1, which in the end will give us 7/6 as a final result. Good. Okay, looking at number 6, we have the function y equals x squared minus 9. We have that graph shown to you. And again, we're finding the area between the graph and the x-axis. And as you can see, the entire graph is in the negative range. So our answer in the end will be negative. But since we are finding an area, we are going to change that and take the opposite value of it and make it a positive value. So again, this is very straightforward. We can clearly see by the graph that it intersects the x-axis at 3 and negative 3. So when we integrate, we do upper bounds minus lower bounds. Remember, we read right to left on our graph of x squared minus 9 dx. When we integrate that, since that's actually a quick integration, remember our rules for integration. And now we're going to just plug in our bounds. So we have 3 to the third over 3 minus 9 times 3 minus the entire second bound. So we end up with negative 18 minus 18, which gives us a value of negative 36. So therefore our area is 36. Check your work. Okay, we're looking at problem number 8, number 7, where it says find the area between the graphs of y equals x squared plus 2x plus 1. That is a parabola graph here is shown. And the graph of y equals 2x plus 5. That is our line here. If we want the area between those two curves, we're going to be looking at this region here. So I took the liberty of finding the points of intersection. Again, you can do that either algebraically or graphically. I did it graphically. I used the table function on the graphing calculator to find the points where they met. Those points, the x values, give us our bounds. So again, when we're going to be integrating our problem, we're going to go from our upper bound to our lower bound of x values. our higher function, or the function that's farther away from the x-axis in the area that we're talking about, is the equation of the line, which is 2x plus 5. And from that, we're going to subtract the lower equation. In this case, it's our parabola, which is x squared plus 2x plus 1. So I'm going to take a minute here, distribute the negative, combine some like terms, and then we'll integrate. Okay, so I took a moment, I distributed the negative to each term, and we left with 2x plus 5 minus x minus 2x minus 1. If we combine some like terms, the negative x squared stays, 2x minus 2x cancels, and 5 minus 1 becomes 4. We're now going to integrate, and again, that's our power rule for integration. And then we're going to evaluate it at 2 and negative 2. Okay, so when we plug in 2, we have negative 2 to the third over 3 plus 4x. So 4 times 2. And from that, we're going to subtract the negative of the negative 2 to the third over 3 plus 4 times the negative 2. We get negative 8 thirds plus 8 minus and 8 thirds minus 8. You're going to need to distribute this negative again to each term. So we're left with negative 8 thirds plus 8 minus 8 thirds plus 8. When you finish that work, you're left with 32 thirds as our final value. Okay, in question 8, we have two functions, f of x and g of x, and we want to find the area between them. I've graphed both functions, and I found the points of intersection to be negative 2, and 1, 1. And again, the values that we care for the intersection of the x values, they are our upper and lower bounds. So we can clearly see that the parabola is the top function and the line is the lower function. And so that's going to help us when we write our integration. So when we integrate, we're going to go from our upper bound of 1 to our lower bound of negative 2. Our upper function, our top function, is the 2 minus x squared. And from that, we're going to subtract the lower function of x. We can do, there is no combining of like terms, so we're just going to go to a straight integration. The fact that the terms are in degree, are not in degree order, at this level of math should not be that big of a deal for you. As we integrate, we get 2x minus x to the third over 3 minus x squared over 2, and again, you're going to use your rules for integration for that. And we're going to evaluate it at 1 and negative 2. Okay, I took the liberty of writing that out just to save some time on the video. So when we evaluate, we have 2 times 1 minus 1 third minus 1 half minus, and now we're going to plug in the negative 2, so 2 times negative 2 minus negative 2 to the third over 3 minus negative 2 squared over 2. So when we evaluate that, we have 2 minus 1 third minus 1 half. We have negative 4, we have negative 8 thirds. That's going to make that positive, sorry about that, and minus 2. Again, when you 2 minus third minus half plus 4 minus 8 thirds plus 2 ends up giving us 9 halves as our final answer. Good. Okay, looking at question number 9, we have the graph is shown to us, and we have two equations. We have y equals x squared minus 3x minus 4, which is this curve here. Now that's the lower curve according to the x-axis. And then we have the other curve of negative x squared minus 3x plus 4, which is this curve here. Okay, and we have the area between the two curves of what we want. The graph was nice enough to give us the intervals that they wanted us to go from. So we have an upper bound of negative 2 and a lower bound of negative 2. So when we integrate, we're going to go from 2 to negative 2. And remember, the upper function is the negative x squared minus 3x plus 4. Now, if you change these values, your answer, change the order in which we evaluate these functions, your answer will be different. So this is, next to your rules of integration, the order in which we write these is the most important. So we're going to evaluate that first function of negative x squared minus 3x plus 4, and we're going to subtract the second. I'm going to distribute the negative sign and combine some like terms. Okay, so we distributed the negative, and we can clearly see now that we have a negative 3x and a positive 3x, that we can now cancel those two terms. I have to switch pages, so I'm going to copy this onto the next page. Okay, sorry that I had to change pages, but the screen froze. If you need to, just rewind the video a little bit so you can see how I combine the terms. So now that we have the terms combined, we're going to do our straight integration, again, using our rules for integration. So we have negative 2x to the third over 3 plus 8x from 2 to negative 2. We're going to plug in our values, so negative 2 times 2 to the third over 3 plus 8 times 2 minus the entire thing, negative 2 to the third all over 3 plus 8 times negative 2. Alright, the next thing we'll do is evaluate this. Okay, 2 to the third is 8 times negative 2 is negative 16. So we're left with negative 16 thirds plus 16. That's going to be a double negative, so it's minus again 16 thirds. Don't forget to distribute, and we have positive 16 as well. When you add that all up, you're left with 64 thirds as our final result. All right, well, good luck tomorrow, and study tonight. Email me if you have questions.